We are now going to look at our second video for today's lesson, and that video is going to be on functions and evaluating functions. So the key idea behind evaluating functions inside the word evaluate is the word value. So the big idea here is finding values of a function at certain inputs, okay? And we're going to start by doing this with a table, and then we're going to expand to doing it with equations. Now, for the first function here, and of course we read this guy as f of x, we want to start with find the value of f of x if x equals 2. Now that's just saying, what is the value of that function at the point where x equals 2? And the way we identify that is we look at the table, we look down here in the x column, and when x is 2, the output for the function is 3, and therefore the answer to this question is 3. Now another way of writing this would be saying that f of 2 equals 3. And what that means is that the function value when the input is 2 is 3. Okay. Now for our second question, we're asked to find f of negative 1. Same idea here. This is just saying, what is the value of that function when the x value is negative 1? And if I look at that one, when x is negative 1, the function value is 9. So our answer would be that f of negative 1 equals 9. Our third question on this slide is find the value of f of 2 plus f of 0. And that really just comes down to finding two separate things. We need f of 2, we need f of 0. Now, we already learned up at the beginning that f of 2 is equal to 3 from the table. And then the question is, what is the value of f of 0? If you look at the table here, f of 0 maps to 7. So f of 0 equals 7. And our answer to this question, 3 plus 7 equals 10. Okay, so that's how we evaluate a function using a table. We can also evaluate these functions given an equation. And if I take a look at this one, the equation that I'm given is f of x equals x squared minus 5. And we'll be evaluating at a few numbers. And if you look at that third example, at a variable expression. So for number 1, evaluate f of x for x equals 3. And what we do is we take the equation part of this, which is x squared minus 5, and we're going to substitute in whatever value or variable they're giving us. So in this case, they're saying that x is equal to 3. So I take that function and I replace the x with a 3. Note that I put that 3 in parentheses. It's always a good idea to put whatever you're substituting in parentheses. And in this situation, 3 squared is 9, 9 minus 5, and that's equal to 4. Okay. You'll find that normally when you substitute a value in, like an actual number, the answer you'll get will be a number. Whereas if you substitute a variable in, your answer is usually a variable. So that's number 1. If I look at number 2, they want me to find f of 1. Just like we had on the last slide, this means that let x equal 1 and then go from there. So once again, I'll take that x squared minus 5 and I'll put a 1 in to replace the x. So I'm looking at 1 squared minus 5. 1 squared is 1. And what is 1? 1 minus 5 equals negative 4. So our answer to this problem is negative 4. Now, if I look at the third example down here, we have f of 2w. The 2w there looks a little tricky because it's not a number. All it really means is that our final answer is not just going to be a number, it's going to have variables inside. So once again, I'll take that x squared minus 5, and I'll put that 2w in to replace the x, like so. So it's still x squared minus 5, kind of, but the x has been replaced with the 2w. Then it's just a matter of simplifying. When I square that 2w, and I'm going to do a little scratch work here on the side, squaring something, of course, means to multiply it by itself. So I'm looking at 2w times 2w. That gives me 4w squared. So my answer here would be 4w squared minus 5. And again, as I said a moment ago, the answer here should not just be a number because what we substituted in was not just a number. Okay, we've got one more set of problems to try here. If you're watching this video, I would recommend pausing here for a second and trying these 3 problems on your own, and then you can see what the answers are. Okay, if you've paused and tried these out, let's go ahead and take a look at what the answers should be. For number 1, we want to find g of negative 5. That means I'm taking this function 3x plus 7, and I'm substituting in negative 5 for x. Note again, I used parentheses. 3 times negative 5 is negative 15. I'll add 7 to that, and that gives me an answer of negative 8 for number 1. For number 2, a very similar question. Find g of 1. Again, I'll take that 3x plus 7 and replace the x, in this case with a 1. 3 times 1 is 3. Add 7 for 10. And finally, the trickiest one of the lot here is going to be that g of 10b plus 9. This is a little tricky. The entire 10b plus 9 will be put into the function. And just make sure that you put it in parentheses when you do. So I start with 3x plus 7. The x is replaced, in this case, with that whole 10b plus 9. And one thing to make sure of when you're doing these, one mistake that sometimes people make is they don't bring down that plus 7 right there because there are so many other things going on. Don't forget that. And now looking at this problem, what we have is an example of the distributive property as we covered last week. We'll take that 3 and distribute it into both terms. So 3 times 10b gives me 30b. 3 times 9 for 27. Bring that plus 7 down. And in this case, our like terms appear to be the 27 plus 7. Those two give us 34. So my final answer on this one, 30b plus 34. That concludes the second video for this portion, for this lesson. Now that you've done this, you should be ready for class when we'll be looking at some practice problems on what is and is not a function, as well as evaluating. Thanks for watching.